Welcome to the Photomodeler Scanner troubleshooting tutorial. We describe various DSM problems and how to overcome them. This tutorial covers a number of specific topics as short segments. The items covered are poor results due to weak camera station orientation, noise due to the range being too small, noise due to a bad approximate surface, improving results by changing texture type and window size, data missing due to view occlusions, and lastly, a review of other potential problem areas. Poor results due to weak camera orientation. Narrow baseline stereophotography is common in scanner projects because it provides the best views for scanning. Sometimes we have a project like this one here. It is a 2-photograph small baseline project that appears to have solved well. See the low maximum residual of 0.16 pixels. This is a piece of paper bent into a wave shape with a random texture printed on it. We run a DSM extraction on these 2 photographs. You can see the results are not correct. There are parts of the surface that look correct, but the other part has a lot of noise. This is due to a weak camera orientation. The program is not matching the same pixels in one image row to the correct row on the other image. With a texture like this, a patch of imagery can look quite similar just a few rows away. The issue is that 2-photograph narrow baseline projects are inherently weak. Even with a low maximum residual, the orientation may not be good. It can be misleading. The solution is to add 1 or 2 more photographs at greater angles to improve the redundancy and orientation quality. Here we have loaded the same project but with a 3rd photograph added and processed. You can see the maximum residual is even a bit higher than the 2-photo project, but is still quite good. A 3-photo project is much stronger and the maximum residual is now a better quality metric. Better still will be if the 3rd photo was from a larger angle. We will run the DSM with the same parameters as before and on the same pair of photographs. You can see a much improved result. In a 2-photograph project, when you see noise that is not explained by other issues, you should try adding 1 or 2 other photos at other angles to improve redundancy. Note that this problem can occur in multi-photo projects too, when a particular pair of photographs has a weak or poor orientation. Adding more precisely marked points to the pair, referencing to other strong angle photographs, and reprocessing will often help. Noise due to an insufficient depth range. Here we have some photographs of a sand pile, which is illustrative of a large stockpile. You can see the stereo pair of photographs simulating 2 aerial photos. We will create a point mesh from these photos with the default depth range seen here. The depth range tells Photomodeler Scanner how far above and below the base surface to search for 3D matches. The values here are default values guessed at by the program given the existing points. You can see the ground level and part of the pile were extracted correctly, but the center portion degrades into a cloud of noise. The telling feature of this noise is that it starts at a consistent height. This points to an insufficient depth range or inappropriate base surface. The base surface issue is covered in the next troubleshooting segment. The base surface used here would be a flat plane on the ground, because these are the current 3D points in the project. The search range will be above and below the ground plane for a short distance. That distance is clearly not enough. Let's run the extraction again, but increasing the depth range above the surface to a larger value. You can see the new point cloud that is selected in red extends beyond the area of the previous run. Let's delete the incorrect mesh and look at the result. You can see how the better depth range has given us the result we want. Noise due to a bad approximating surface. We use the same sandpile project as the previous segment, but we'll address the base surface issue. If a surface has not been manually created and selected before starting DSM, an implicit surface is created. The implicit surface for this project would look something like the one shown here. is a flat plane going through the existing coded points. Here, we've added some new points to the project by picking natural features. They don't have to be that accurately marked if we don't reprocess the project. You can see how the points are above the ground plane now and a bit more representative of the sand surface. Let's see an illustration of the surface DSM would use now. It is a rough approximation of the real surface. That is often all that is needed. We run DSM again with a small default depth range. DSM will use implicit surfaces created from 3D points on the ground plane and the new marked points. You can see, even with a small depth range, we get a superior result because our approximating surface is a closer match to the real surface. When you see noise that occurs in one part of the surface and appears to be cut off on a sharp plane, consider the depth range or the approximating surface may be incorrect. To improve the approximate surface, mark reference points inside the trims that are on the surface being scanned. Improving results by changing texture type. Here we have two synchronized photos of a hand. Let's create a point mesh with the default parameters other than will increase the range above the surface. You can see how some smoother areas of the hand have sparse point data. There are certain textures, and skin is one of them, that at certain resolutions the texture in the matching window looks very similar. This causes the program to throw out the similar matches. The end result is a sparse point cloud that is not useful. We can tell the program that this is a different type of texture by using the advanced setting called texture type. For new projects, it defaults to 3. We'll change it to 1 and reprocess without any other change. You can see we have a denser result. When an object has a weak texture, sometimes increasing the window size will help. This will use a larger area for matching, increasing its likelihood of being unique. If lowering your texture type increases the noise significantly, try increasing the size of the matching region radius. If your point cloud is much less dense than you expect, and you have ensured that other factors such as project quality and object movement have been dealt with, then consider lowering the texture type and optionally increasing the window size. Data missing due to 3D occlusions. Areas of the surface that appear in both photographs of a pair are scanned and can produce 3D data, but if an area is occluded, that is, something hides the area from one or both of the photographs, it will not have 3D data. We have a project of a footprint with 4 photographs. We have created 2 point clouds from photographs 1 and 2 and photographs 3 and 4. In the 3D view, we see the point cloud from photographs 1 and 2. The cloud looks relatively complete from this view. We rotate the view and can see holes in the cloud. These holes are the result of 3D occlusions. These areas were hidden from view on this pair due to the angle of the cameras with the surface. The other pair of photographs is from the opposite angle. Let's look at its result. You can see it has holes from the opposite side, but is complete in the other areas. Combining them will fill the majority of the occlusions, and this will be a good basis for merging and meshing. We can often fill 3D occlusions through careful choice of alternate photograph pairs with different angles. Other problem areas. We've demonstrated some common problems when using Photomodeler Scanner. The following problems are due to inappropriate project setup, and often the photographs will need to be retaken. In most of these cases, you will see excessive point noise or lack of 3D data. The problems are a subject that moves between photographs. This is common with human subjects. The solution is to use multiple synchronized cameras. Lighting that changes between a pair of photographs. This can be a flash mounted to the camera or other light sources that are moving and changing the look of the surface between photographs. Moving lights cause more problems with specular and reflective surfaces with dents. The solution is to use fixed lighting. Photographs that are out of focus will often lead to poor results. Ensure the whole surface being scanned is in sharp focus. Photographs that are at convergent angles over 10 degrees will make the surface look too different in photographs, and scanning will often fail. Make sure your photographs are close to parallel and not too convergent. Add other convergent photos to the project that won't be processed in DSM if you're having trouble solving the basic PhotoModeler project. Lastly, surfaces that have little texture, such as metal or glass, will not scan well. You may be able to paint or project a texture pattern onto the surface before photography. This concludes the PhotoModeler Scanner troubleshooting tutorial.